After Saturn V and the moon landings, NASA set out to build something new, a reusable spacecraft. Part rocket, part airplane, the Space Shuttle was the first vehicle designed to reach orbit, return, and fly again. The Space Shuttle program was an extensive and ambitious project. Conceived in the late 60s, built in the 70s, and flown from the 80s onward. Unlike rockets built for a single mission, the shuttle could carry astronauts and heavy cargo into orbit, then return to land like a glider. To prove it could work, NASA put the first shuttle, Enterprise, on top of a modified Boeing 747. Carried to high altitude, it was released and glided back to the runway without engines, proving that a reusable spacecraft was possible. Every orbiter was covered in a multitude of thermal tiles, each one unique, numbered, and checked by hand. They weren't metal plates but lightweight ceramic blocks, mostly hollow like tiny bricks. Fragile to the touch, yet able to withstand the fire of reentry. Glued to the surface, a single missing tile could have created catastrophic consequences. The cockpit windows look small compared to airliners, but they were engineered for toughness, not much for views. Each was more than twice as thick as an airliner's, strong enough to withstand impacts from tiny, high-speed space debris. They gave astronauts a safe view of Earth, space, and the vast cargo bay. One of the first things astronauts did after reaching orbit was to open the cargo bay doors to help cool the shuttle. While in space, the orbiter could be oriented to optimize communications or dissipate heat, and the crews typically stayed aboard for up to 2 weeks. The shuttle also orbited tail first, so the main engines were already pointing in the right direction for entry. When it was time to return, a short engine burn slowed the shuttle enough for gravity to pull it back into the atmosphere. The shuttle always re-entered belly first, with its heat-resistant tiles protecting it from intense heat and friction. Re-entry was the shuttle's most dramatic phase. From orbital speed, it transformed into the heaviest glider ever built. On final approach, it dropped faster than a commercial airliner, touching down at speeds higher than most passenger jets. A parachute deployed on landing to slow the 100-ton spacecraft. Landing had to be flawless. Once it touched down, there was no engine to take off and try again. Incredibly, on STS-80, astronaut Story Musgrave even stood up during re-entry, calmly watching while the shuttle blazed through the atmosphere. The shuttle's cargo bay was enormous, large enough to fit both the Apollo lunar module and its command module together. It wasn't just empty space, the shuttle carried satellites, labs, and even the building blocks of the International Space Station. Its most famous tool was Canadarm, a robotic arm that could grab satellites, move equipment, or assist astronauts during spacewalks. To reach orbit, the shuttle relied on 3 parts: the orbiter itself, 2 solid rocket boosters, and 1 massive external tank. The boosters were recovered and reused, pulled from the ocean after each flight. The external tank, however, was left behind to burn up in the atmosphere. Initially painted white, NASA later left the orange insulation exposed, saving precious weight. In 30 years and 135 missions, the shuttle carried astronauts, launched satellites, built the ISS, and even repaired the Hubble telescope. 6 orbiters were built. Each was designed for 100 flights or 10 years, though some exceeded that lifespan. The program had triumphs and tragedies, Challenger and Columbia, but it proved that reusable spacecraft were possible. Story Musgrave reflected on its legacy. We are incredibly mature now, we are incredibly sophisticated, and we have learned how to operate a very difficult thing. Today, as we look towards Starship and future spaceplanes, the shuttle remains a benchmark. A bold experiment that launched like a rocket, orbited like a spacecraft, and landed like a glider.